Brenden Macaluso. Many of you know him very well, and I'm very happy to introduce him to us. And he graduated from UHID program in 2008. Mm-hmm. And I know him very first time from his senior thesis project is recomputing. And many of you probably seen his product design. So basically rethink a way to design the PC, personal computer. And since then, he practiced design and being an entrepreneur for the last 15 plus years. And today, I'm very glad to introduce him to give us his understanding and I think personal experience and practice regarding the sustainability in design. So Brenden, please feel free to start.
Okay, very good. Well, Jeff, thank you for hosting me. Thank everybody for joining the meeting here. This lecture is going to be based around my own kind of personal take on sustainability and my own experiences as starting back when I was at U of H and my thesis work and kind of what has manifested to today. So this is all kind of been in practice from day one. So let me go ahead and move to the video real quick, and we will on this video the lecture and start there. Cool. We're good. Can everybody see the lecture?
Yes.
Good. Mm-hmm. All right. So let's get started. So my lecture is titled "Sustainability by Design, Maintenance, and Planning," and trying to look at a bigger look at ID. And what we have here is some e-scooters, the rentable e-scooters, which is a whole big problem. And just wanted to show that as an example. Real quick on these things, they have a service life of about 3 to 6 months before they end up here, plus a bunch of other social problems they've caused. So that's something to dive into on your own in case you're curious about that. So I want to start off with an anecdote. I want to say, first of all, I don't have all the answers to sustainability. So these are just ideas I want to share with everybody to be considered as professional designers working in the field as students, and how we need to be responsible for certain things coming into our careers as industrial designers. So when I was at U of H, we had an adjunct professor named Jack Zellner. He was there for about a semester. He was an experienced professional. And he told us a story about when he got out of school in ID, he worked for a company called Zenith. And if you're fairly young, you may not be familiar with Zenith. They were an electronics maker. They made, radios and televisions and turntables and things like that. U.S. maker, around for many years. It no longer exists. And Jack got a job at Zenith right out of school, working in the cabinetry shop. Because back in the day, in the 60s, electronics like this were also part furniture. We don't see it so much now, but definitely back then, objects like this worked. And Jack's work was designing prototype cabinetry for these different electronic elements. So here's a turntable record player, radio setup. Like here's a television. I remember this kind of stuff as a kid. That was on the floor, and so it was a big fixture in the house. And Jack's telling us the story, and then he says, I did this in the late 60s. Where do you think all that stuff I designed for Zenith is now? And there was kind of a blank look across the room, and he goes, it's all in the landfill. We as industrial designers make landfill. Keep that in mind as you move forward in your career path. And that moment really resonated with me. And I said, okay, wow, I never thought about it this way. What am I doing in ID? How can I think about it different? And it pushed me into my where my thesis was. So not to be all gloom and doom, I do want to share with you kind of a funny thing. The Simpsons, I can always say, are great satire on reality. Here's a clip kind of talking about this type of stuff.
Gentlemen, I'm pleased to report strong holiday sales from the Christmas, Hanukkah, Kwanzaa spend phase, and things look good for the mom-dad grad gift card. Then we'll have the usual summer lull, but hey, we're making enough money, right? Hey.
Okay, people, we need to cook up a new holiday for the summer. Something with gifts, cards, assorted gougeables.
How about about something religious? We had great penetration last spring with Christmas too.
Oh, I know. Spend over like Passover, but let's talk more presents.
Right again.
Skip.
No. Oh, it's got to be warm and fuzzy. Something like Love Day, but not so lame.
Happy Love Day, everyone! Come on, Mom. The stores just invented this holiday to make money.
Lisa, don't you ruin another Love Day.
For you, homie.
I'm Sir Loves a Lot, the bear who loves to love.
They didn't have Lord Hockington?
It's the same basic bear, homie.
Good.
What the hell is this? It's a Kisses Make Me Boogie-O lantern. Kiss it and make it boogie.
Kiss it.
Maybe later.
Oh, yeah.
Well, we better start our Love Day cleanup. You kids take care of the wrapping paper. I'm going to dismantle Loveland. What a terrible waste.
Yes, but the memories will last a lifetime.
It's full, Dad. That means you have to take out the trash. Yep, that's the rule. He who tops it off, drops it off.
It isn't filled until it's spilled.
I want you. I want love you.
No, we'll go. Hey, pause that. Move on. So anyway, I hope that kind of gives a little bit of framework of, we make a lot of stuff as ID. A lot of it ends up being ultimately landfill and garbage. And the part one of this lecture is like, how do we get here? How do we go from this level of making all this new stuff and things that we put a lot of energy into for it to ultimately end up in the garbage down the road? And the answer to the question is consumerism via obsolescence. So let's talk about obsolescence as a subject here and how that has really been driving our consumer economy from, since the kind of the early days of industrial design. Quick history here. This is Alfred Sloan. He was president of GM in the 1920s, and in the early 20s, he introduced the annual model change because he was competing against Henry Ford and the Model T. And so they started making a slightly different car every year so the consumer would want to buy a new car. Now that moved forward into the 50s. Brooks Stevens, a very famous industrial designer from the 50s all the way through the 80s. And Brooks Stevens was a big proponent of this planned obsolescence. And he wanted to make, the newest, latest, greatest, so people would actually want to go and buy the next thing. And he was a big pusher of this. You can actually look up a lot of his lectures and talks about this idea to continue that cycle and going. So industrial designer right here, pushing planned obsolescence. And I'm going to talk about how does planned obsolescence manifest. And there's a few different ways in which it shows up in our current world and some things that we've all experienced. Number one is going to be a forced change. We see this a lot with technology, whether it's software, making us update to the latest and greatest, or, in this case, we have a router with your internet. I recently had to do this. I had a cell phone that was a 3G, 4G compatible cell phone. It was a Motorola phone. And AT&T decided they're no longer going to support this model because it was also 3G compatible, and it forced me to have to buy a new cell phone, which my cell phone was just fine. So we get a lot of this kind of forced change, especially with electronic devices and things with software. We have that latest and greatest type of feeling, whether it's electronics, got to buy the new car, got to buy a new thing. This is definitely along the lines of what Brooks Stevens was talking about. And we continue to make new things consistently and always got to have the newest, keeping up with the Joneses, whatever you want to call it, type of manifestation of obsolescence. We have rapid architecture and compatibility changes. We see this a lot with how pieces come together and how things are maybe reverse compatible or not. And I say, okay, let's think about something simple like Legos. And the idea of Legos are built on a very consistent platform of sizing and scale. So now, let's say Lego said, okay, every year we're going to change one dimension on the Legos to be a little bit different. So last year's Legos are no longer compatible with this year's Legos. And we do that every year. All of a sudden, we're going to have a bunch of Legos that are all slightly different from each other and don't work. And I think this illustration kind of demonstrates that idea of how that can spiral out of control very quickly with design. So Lego, I don't think would be here had they done things like that as a company. Manufacturing build quality. There's a lot of stuff that we make that's just really poor build quality out there, whether it's not made to be serviced or it's just overall junk. I had this Duralast. This is a battery jumper for jumping your car battery. My friend gave it to me. He didn't need it anymore. It was brand new in the box. I went to go use it for the first time, and the plug in the back of it to charge it in the outlet had fallen out of the inside of the case. So I decided I'm going to open it up, try to put the plug back in position, and turns out the way this whole thing was put together, it literally fell apart in my hands. I don't even know how they put together the factory. Every piece was so fragile and delicate that it came together just ever so perfectly that you couldn't even service it and work on it. This thing came out of the box new, was never used, and I ultimately had to take it apart, recycle what I could, and throw the rest away because it was that poorly made. It was absolute junk. Now, this is the level of obsolescence that I'm going to talk about a bit more here in the lecture, is that a product is no longer supported, or support can be proprietary for that product. And that shows up whether it's going to be availability of parts and parts availability, information, or a support network or knowledge exchange. So if you don't have these elements, a product becomes obsolete very quickly because these are needed in the usage stage of the object in order to keep it going. So I said it manifests parts, information, knowledge exchange. That's kind of how it all flows together. You got to have all three in order for an object to continue to exist. Now, some other things just have a natural attrition to them. I think this is an interesting dichotomy here, where you have something like a boat that this could have been maintained or taken care of, but it's just been allowed to decay and fall into disrepair, as opposed to something like a skateboard, which wears in use. Like, that thing is going to wear out. It's not going to be fixed. It can't be repaired. It's just going to kind of be used up, and that's it. So the natural attrition of objects is kind of factored into obsolescence, and we kind of take that for granted because it just happens all around us. The pair of shoes that wears out, or something that just wears out with use that isn't always repairable. And I get that. I understand that not everything falls into a category of sustainability. The other things that could be is that the company who made the products doesn't exist anymore. American Motors is a good example. If anybody's familiar with them, they're America's fourth largest auto producer that's been out of business since the mid 80s. They are absorbed by Chrysler, but some of their products are still on the road. On this car over here is a Ford Contour. This was an example of a product that was brought to market that did poorly in the market. Actually, this was a global product that Ford had made and sold around the globe. It did really poorly in the US market from the mid 90s to the early 2000s, and therefore Ford kind of pulled the plug on it and didn't want to support it because the sales were poor. Not because the product was bad, because the sales were poor. So those are different reasons why the product is now considered obsolete. If you want to talk, look a little bit more about planned obsolescence, this is a great documentary out there called The Light Bulb Conspiracy. It's about an hour, 15 minutes long. You can watch it for free on YouTube. As designers, I highly recommend you check it out. It goes really in depth about how there was cartels making the life of light bulb shorter and shorter and shorter on purpose, so people would buy more and consume more. On the other side of the screen here, this is one of the oldest running light bulbs in the world. It has been running for over 120 years. It's at a fire station in California, and there's actually a camera on it. You can watch it in real time, still burning. So there were light bulb designs out there that could last a long time but didn't have to be replaced. So definitely check out that movie as a designer. So what I'm kind of framing up here is our tug of war of obsolescence versus long life. And in this dichotomous example here, yes, I understand that the Apple Watch is not just a watch; it's a little wrist computer thing. But the question I pose is, which one of these is going to be useful in 25 years, right? Which one has that staying power because of its purity in design, its construction quality, and its ability to do its job properly? I don't think the Apple Watch is going to be useful in 25 years, but something like the Shinola watch, they're built in Detroit, all mechanical, will still be around and serve its purpose as a watch. So I'm trying to keep these type of things in mind as designers. What's going to happen to our stuff down the road? Our e-scooter situation, but short life. The pitch was that they were going to help urban environments and save all those emissions and greenhouse gas, and people are going to get around easy. They've caused, I think, more problems than they've solved. That's a whole other issue to dive into. Expanding on the idea is this. That's an aerial shot of trashed bicycles from bike share programs. This one happens to come out of China. Well, these are these bikes that were floating around the cities that had little GPSs on them and self-lock. So you'd use an app to unlock the bicycle and go right around. When the support companies stopped doing the support for these things and they weren't making money, a lot of that stuff got trashed and just thrown away. Many of the bicycles were built with proprietary components. A lot of them have electronics and batteries in them as well, which make them difficult to recycle or turn into scrap. The photograph of it, it's actually a bigger problem than people think. So it's this overlapping, good intentions of sustainability applied, but this is the reality of what happened versus, the pitch and plan and thinking about that bigger, long life picture of what happens when things don't work out right. So this gets into our second part of this lecture here. I said just the slice or the whole pie. And this is going to be in regards to how sustainability has been framed up a lot of times for industrial designers, especially over the last 15 years. So about 15 years ago, we saw a lot of this green product showing up on the market. Sustainability was a hot topic. It was coming out of architecture world. It was bleeding over into ID. And I saw it manifesting in two ways. And I still kind of see it manifesting in two ways across ID. One is how products are made, or I guess the materials products are made out of, right? So we make a product out of a certain material, therefore it is more sustainable. Yes, no, maybe. I think it depends on the product and the materials we're talking about. This is a radio called the Mango. This was made out of bamboo and some other wood that was easy to grow and easy to reclaim. Is it more sustainable? I don't know. It's to be determined because it's still a radio. The other way we saw sustainability manifest is how much energy does the object use in its existence, right? Once the consumer gets it in its hand, does it use a lot of some kind of resource or does it use a little of resource? And neither of these topics are bad. Neither one of these angles are bad, but they're very shallow. And this is why I was saying it's just a slice of the whole pie in thinking about sustainability, because there's a lot of what I call greenwashing out there. We've heard that term, that because these objects embrace or embody, materials or energy consumption, therefore they're greener and better. Yes, but again, it's not the whole size of the equation here. What we really need to get into is what the whole pie is, I should say, is product life cycle. We have to be thinking about the products we make all the way from the design phase, which is in our hands, through the manufacturing phase, into the usage phase, and then an end of life stage. Now, we know as humans, we have these phases kind of figured out. We know that, what to do with a baby, what to do with a child, what we do as an adult, and we also know what to do with people when they die, right? We haven't quite figured that out for the things that we make yet, but it's applicable because we put so much energy into this stuff. And it's important to think about. So this is what I call the simplified product life cycle. We're going to break it down a little bit. I'm going to look at my notes real quick here because I've been kind of going off. All right, so let's talk about the first two stages, which are design and engineering and manufacturing. And I put these two together because they are closely related. And this is what's in control as us as designers, and also in control with the companies who are making the products out there, because we're all kind of tied at the hip as far as manifesting products into reality. And at these stages, we need to consider things like the manufacturing process. We need to consider things like the number of parts and types of processes used at the various stages or during manufacturing. We need to avoid what I call the Achilles heel syndrome, which is having elements that, one thing breaks and the whole thing is useless, much like that example I was showing with that jumper pack. And we have to think about, all right, as we're designing things and as we're making these things, how do we make them last longer? Like, how can we implement that as an element on the table into our design? And I don't think that question is answered enough or asked enough or even asked at all when we're making things. It tends to be just, we're making it, we're solving this problem, we're solving this brief, here it is, it's made, it's done, next thing, right? But we actually need to be considering this stuff, because during this design and manufacturing process, this is where we have the largest investments into the product. This is where the energy goes in to make it and the resources that go in to make it. So before an object even hits the shelf for the consumer to buy, we've already invested a ton of energy and resources just to make it happen. And this is what I call a down payment in energy and resources. And with that in mind, it leads to ask the question, well, we've already put all this energy and time into things, why are we throwing them away so fast? Why aren't we trying to get the most we can out of the things that we've already made? Hence my Simpsons clip right there. We tend to throw things away because we don't understand how much it takes, how difficult it is to make the things that are in our world, unless you're on that front line doing it. And I'm not asking the question. So this is where I really want to harp hard on this one, because this is, I call our down payment in energy and resources. Well, let's look at some dichotomous examples here of it. In that manifesting of design, do we have something that's complicated in its manufacturing, lots of parts, lots of components, lots of processes used to make it, on top of an object that also has another level of consumption on it, right? So we have our Keurig here, which, yes, is beautifully convenient for a lot of people who don't know how to make coffee, but I challenge you to think that if once one element on this Keurig breaks, what's going to happen to it, versus something very elegant and simple like a French press that has no electronics, has no moving parts, and still makes delicious coffee. And it's going to last a long time. So, both of these make good coffee, and that's the end result of what we want of them. Which one is going to have a long serviceable life of use, and which one, let me back up here. I also want to say that, the more complex an object is, the more parts it has. The more parts it has, the greater chance of failure of the object is, because a part will fail, and if it fails, then it's more likely to be disposed of versus repaired. So simplicity versus complexity, because of the nature of how many parts and pieces go into an object. Costs. Common off-the-shelf items or standardized parts and components. Now, I didn't come up with this term. This actually came from a different professor I had at U of H, Joe Meppelink, and he was talking about, in architecture, but it applies to things and decisions we can make in ID, and I see it all the time. So we're going to look at this example of this little Yeti tumbler here, kind of a very simple object, not that many parts in it, but we do have a lot of processes to manufacture it, a lot of different materials here just to make this simple cup of an object. And I'm going to look at the lid. And so here at my house, I have a couple different of these coffee tumblers. They all have different lids, and they all have different rubber seals on the lid, which is kind of the critical component to make sure that lid works properly. In this case, we're looking at a seal that has a proprietary size and shape just for Yeti, just for that lid, to do the job of sealing the liquid inside the cup. And I would challenge a designer to say, you don't need to make a proprietary seal that you may not get a replacement for. Why don't you use something like an O-ring, which is a commonly available off-the-shelf industrialized product? And I would go even further and say, why don't you, put the O-ring size into that plastic, when that plastic's being injection molded, put the size of the O-ring in there, so in case it does fail, you know what size to buy in the future, right? Simple things like that. And those are the elements I think about, because that can be the Achilles heel of this very simple product right here. It's a seal failing or being lost or eaten in the dishwasher or whatever, Let's go to another example here that I experienced. This is the control panel off of GE dryer, very similar to the dryer that I have here at my house. And I'm going to focus primarily on this switch right here, which is the start switch. The way this was designed is you actually have to take the switch and turn it a few degrees clockwise to start the washer. So not only is the interface of this one kind of weird for what the switch is, it causes the switch to break because you're only supposed to move the switch, you know, between those two toggle pieces to start the dryer. It didn't have a very easy to think about interface. And I went to go replace the switch on the dryer. And on the left here, we have the original GE switch. And as I'm studying the switch here, I realized that this switch was designed for, you know, its main purpose and design really wasn't to be a switch that gets constantly used, because every time that dryer is turned on, you got to use the switch. This switch was specifically designed to be installed quickly at the factory by the by the people on the assembly line to get the product out the door. And when the little plastic tangs on it broke, that meant the switch didn't work right and didn't mount in the back of that control panel properly. Now, the proper fix would be to buy the switch and the whole control panel and swap all the parts out because of this like weak design, like it's poor injection molding plastic. And that switch is expensive. That's a $40 switch. All it does is click on real quick. On the other side, I repaired it with one of these. This is a very simple industrial momentary switch. I bought at the hardware store for $4 with nice brass terminals on it. I put that switch in, haven't had a problem with the dryer since, but this is a standardized off-the-shelf component to do a simple job that did not act as an Achilles heel as is the first one did. In fact, when I was looking for that picture of the control panel, I came across a classified ad for the same dryer I have on the internet, and it was broken in the same exact way. Just needs to have that switch fixed. So it tells you there's a design flaw right there that can be a problem, an Achilles heel type of scenario. So common off-the-shelf products, because there's a lot of things that are already made out there, a whole world of little bits and bobs that we can already integrate into our design that we don't have to reinvent the wheel for. I see that all the time with ID. We keep reinventing things that we don't need to reinvent, but are already there. This is a great book focusing on this idea. It's called The Toast Project. It's this art student out in the UK. And what he does is he decides he's going to build a toaster from absolute scratch. He goes and he mines his own iron ore. He builds his own furnace to smelt the iron. He attempts to cast his own plastic. It's a really fascinating read. It's an easy read too. And it's just kind of his, like, what can I do with the resources that I have as an individual to make this? Hello? Oh, someone chimed in. All right. Here's another picture of Thomas's toaster. Again, as an ID student or someone's an ID, I highly recommend the read. It's a really good, fun read just to see how difficult it really is to manufacture a product, especially from scratch. And he tabs up how much it costs. It's like a couple $1,000 to make this thing, and it doesn't work. He does plug it in. So our next stage in the product life cycle is the usable life. And this is where I spend a lot of my day-to-day life here. And this is also the spot where in ID and in manufacturing, we tend to stop our thinking. Hey, we designed the products, we came up with the final concepts, we got it built, we got it made, it's on the shelf, it's for sale. All right, we're done. Our job is done as ID. And I challenge you to say, like, no, it's not done, because now this product exists in the working world, and it has to now interface with users, and it has to be supported throughout its existence with those users. And those users are anybody from the people who are, you know, actually buying and using it on a daily basis, but also maybe the people who are working on it. Like, who are the different people that this product is having to engage with? And are we designing for all those different people or different users in mind? You know, I do have a background in auto mechanics, and I can't tell you how many times I've worked on a car where trying to access what should be an easy to get to part is almost impossible because of how it was put together at the factory. You know, the mechanic got the short end of the stick, even though they're having to put all that energy in to try to repair the product. So, yeah, going back to my notes here. This is one of my notes pages here. We realized the objects will break and need service. Was this thought about during the design process? One. And two, who will be doing the service work? Is it a specialized technician, or is it the average person? How easy is it to do this type of repair and service work and maintenance work while the object is in the wild, usable world that we're in right now? This is the Right to Repair Manifesto. This has a lot to do with electronics, but you guys can jump in on the internet and look at it a little bit deeper. And basically it says, if we own something and we buy it with our money, we should have the right to be able to fix it and repair it. And if you're not able to do those things, you really don't own it. You're just kind of leasing it. So a lot of details on that. I don't want to dive into it too much, but it's definitely something you should check out. I believe in the philosophy of it and what it stands for. So this is going to lead into our next little section here. Let's talk about this thing. This is a Tesla. I think it's Tesla Model X. And I think this is a good example of what I call kind of a greenwashing effect in sustainability. Whereas the pitch is the car is electric, it's state of the art, it doesn't use up fossil fuels, but it's a very complicated object, very expensive object, luxury object. So there's a lot that went into making this vehicle, and on top of it, Tesla doesn't want to support it. So let's kind of get into that side of it here. This is a fellow named Rich. He runs a YouTube channel called Rich Rebuilds, and he is running kind of the first Tesla salvage yard because Tesla doesn't want to do too much about it. I'm going to show you this video. It's going to be easy. We're going to watch a few minutes of it. You'll get an idea of the reality of this product currently in the world beyond the showroom.
They're exotic, they're surreal, they just look like nothing else on the road. So much engineering time, effort, and hours went into creating these masterpieces, but there's also a flip side. Tesla's stance on rebuilding vehicles is only they should be able to do it. Now, I would say I'm the first person to bring a Tesla that's completely dead to running and driving almost showroom floor quality independently by themselves. At this point, I would consider myself the Dr. Frankenstein of Teslas. People need to know more about the products they own. If you own something, if you purchase something free and clear, then you should be able to fix it yourself. I don't want people to think that they're too small to have a major company make changes. Don't feel that you're not being heard. You do have a voice. My name's Rich, and I run a YouTube channel called Rich Rebuilds. I also go by Uncle Rich, Car Guru. You're probably asking yourself, Car Guru, what are you doing in that sweet, sweet race car bed? Well, you think my life is all fun and games? Here's some of the things you have to deal with when you hobble together two broken Teslas to make one working Tesla. This car's been sitting for so long, you just don't know what's going to happen. I think if someone would have watched the channel, they'd probably describe me as a DIY enthusiast to the extreme. / Tesla vigilante, honestly. They'd probably say.
That SDU screen doesn't look so clean.
It doesn't. Sorry, I can fix that right now. You may hear some clicks. You may hear some buzzing. The car may explode. I don't know what's going to happen. So, no freaking way. The door handle's just extended. Oh, Jesus. Oh, my God. This car's been sitting for over a year. I want people to have their cars work. I want people to enjoy them. I'm just trying to help. It may not come across that way sometimes, but, there's a reason why I've owned 10 myself personally. There's a reason why I physically touched and helped people build over 100 cars already. Uh-oh. Whoa. First time it's ever happened. That's all right. Tesla's the gatekeeper to us repairing our own goods because they want control over Tesla fixing the cars. They want control over Tesla selling you the parts. They just want everything under their control.
How may I help you?
Hey, how you doing today? I have a P85. I need those little lug nut covers.
What do you need those? What?
Oh, sorry. Hold on 1 second. Hold on. One of the things I enjoy is calling them out their mistakes. You think Tesla's out here playing games? Tesla wants answers. Oh, hello. Sorry about that. You still there?
Yeah.
I think a fundamental consumer right is your ability to fix whatever you rightfully own. The fact that people don't have another alternative but to go to the manufacturer, that's a huge issue. There's a lot of gray area as to what you actually own with these cars, because in order for the major functions of the car to work, they have to talk to Tesla. I live in Massachusetts.
Anyway, I'm gonna stop that there, but you guys get the idea of what's going on here with Rich. He has a whole channel. It's really great to watch. You should check it out there if you're interested in more of that. But proves my point about being able to maintain and repair the objects. Yep, let's go. Come on. There we go. All right. Sorry. Next. All right. We're moving too fast. All right. So our last part of our product lifecycle simplified is our post-usable end of life stage. So, and this is kind of the big question mark, because we really don't know what to do with a lot of the stuff that we've made. In this example, we're looking at a bunch of cars and a salvage yard. Hopefully those parts are useful. People can disassemble them and use them to keep their other vehicles running. But there's a lot of things that, because they were never designed to be thought about what happens to them at the end of the life, we just don't know. And I don't have a good answer for this. And I think it's really going to be on a case-by-case basis of what to think about in that end of life of the object based on the object. So let's talk about this applied. These 3 stages of kind of or I should say 4 stages of the product life cycle is what I was doing when I came up with Recompute back in my thesis work at U of H. We're looking at what did it take to manufacture this product, and keeping those environmental impacts down and minimizing there. Now, how long could we use the product for, and how do we configure it in such a way that we could use the product as long as we could, because we knew it had a finite life. And then we also had an end of life plan on where it was supposed to go down, or the different channels it was supposed to go down, that was better than what was currently being done with a lot of used PCs at the time, and it still is a problem with a lot of e-waste right there. So in that sense, the product was successful. We had brought it to market. There's a photograph of it at a Fry's electronics store, which is also no longer, there's no more Recomputes and there's no more Fry's, but at a consumer level, it had a lot of problems and difficulties for people to comprehend. That's a whole other lecture into itself. But as far as applied sustainability, this is what came out of all those thinking ideas applied to a certain type of object. Let's go to part 3, the ship of Theseus. I don't know if you guys are familiar with the philosophy thought. It's a thought experiment called the ship of Theseus, and what it is it says the ship of Theseus is made out of 1,000 planks of wood, and every year for 1,000 years, 1 plank of that wood is changed. And after at year 1,000, basically every single original piece of that wood would have been changed. And the question is, I guess in the philosophy argument, is at what point is it no longer the original ship? Is it when that first piece of wood is changed, or is it the last piece, or is it 50%, et cetera, et cetera? I thought about this a lot, and I said, what does this really mean for design, though, in our real world, outside of the world of philosophy? And I put my own spin on this idea of the ship of Theseus, and it has some assumptions in the initial thought experiment. And the assumption is, yeah, you're going to take the ship apart and change the plank of wood out. So I say it's not important whether it's the same ship or not, but rather acknowledging that the ship can continue to exist in perpetuity by the fact that it can and should be repaired and maintained. It says it can exist. We're going to make it exist because we're maintaining it and using it. And I think that's kind of a layer there of this thought experiment that's not really talked about. We're assuming we can fix it in the times of old wooden ships. So I like to keep that in mind when we're dealing with things out in the real world. And that applies into a bigger thought of what I call long life design. Now, inherently, things are going to break and thus will need to be repaired. As designers, we can make this process easy, accessible, and affordable to the user to repair objects they own rather than discarded. Therefore, it's not just about the design of the object itself, but rather how the object is moving through its life cycle and the resources and the systems that are implemented to support the object along its journey. So we're not just designing the thing, we're designing the whole system that this thing needs to live in all the way to the end. That's what we're designing. That's the bigger piece of the pie that we have to keep in mind as designers and ask those questions on. So if we continue to support a product for long life design, it does facilitate a few things. One, it extends its usable service life. We're going to maximize that down payment of resources put into that object. Two, we're going to create secondary markets, whether that's for the objects, whether it's services, parts, modifications, etc. We definitely see this a lot amongst different objects. Three, we're going to empower the users to become the do-it-yourself stewards of the items they own. They have to. Four, the cannibalization of items slows down the end of life stage. So basically, instead of something throwing away, people keep things or cannibalize them because there's useful parts, just like Rich did on his video. So those are all things to keep in mind as part of long life design. Come on. Let's talk about some examples of some long life objects here. One of my favorites, cast iron frying pan, single form, single material object. That's going to outlast all of us and still make delicious bacon for everybody. Like, definitely one of my favorite objects of long life design. Red Wing shoes. Now, they have a reputation that people have, had them so long they don't want to get rid of them, and actually have the shoes repaired. And that's kind of a motto that the company is built on, is the fact that they can, how durable their shoes are and how long people keep them and use them and repair them. Zippo lighter. I thought I was kind of meta finding a picture of a Zippo lighter with an exploded diagram of the Zippo lighter on it. A very simple object, but it does its purpose very well of providing a flame when needed, as opposed to a disposable lighter. Something, again, a very simple, iconic object there. This is a picture of a Hewlett-Packard LaserJet 4 printer. I brought this one up because I owned one of these printers that was produced in 1996. I retired it about 3 years ago. So I got over 20 years service life out of an electronic object, which is a lot of times unheard of today. This printer is built so well, it just kind of kept working, and it got to the point where there just wasn't parts available for it anymore. So we took it out of service. But funny enough, it still has a value on the secondary market. These guys are selling a refurbished one for $229 in case you want it. So a printer that's almost 30 years old still has service life because of how it was built, especially electronic. That's mind-blowingly amazing. So yeah, LaserJet 4 for the win. Coleman lantern. This is a very simple object. In fact, it's so iconic, it's part of Coleman's logo. Gas lantern. I was out camping with this a couple months ago, and someone saw it. They didn't know what it was, and I showed them. They're like, "This isn't like a flashlight with batteries." So I was like, "No, it uses gas, or uses white gas fuel, and it'll run all night. It'll be super bright." And it was something they'd never seen before, experienced. This whole thing comes apart. You can service it, take it apart, and they just work. I don't know. It's a very simple object. Fender Stratocaster guitar. There's so many layers of ID on top of this thing, and culture and reference. It's mind blowing. There could be a whole presentation on this, but long life design. This is like the Legos of rock and roll right here. Very, very, very important piece of ID and long life and sustainability right here. This is a Honda Super Cub. This is kind of the transportation of the world. These were built from the late 60s all the way up until the early 90s. This is the basic transportation, and they're kind of built like a tank. They don't break, they run well, and they provide that simple transportation, especially in developing nations, for a lot of people. There's some great videos online, people trying to destroy these things, and they keep running. So that's another great piece of iconic long life design right there. One of my personal crush right now, my favorite long life design objects is the Ford Ranger. We're talking about the original Ranger, produced from 83 to 2012. That's a picture of a 1983 Ranger right there. And there's a 2012 edition. This vehicle was produced for 29 years, virtually unchanged. Now, there were subtle changes, but basically the 83 version and the 2012 version are almost identically the same vehicle. Lots of parts availability, easy to work on, long life. The engines in these things were built so well, they can go 500,000 miles. A lot of them do. And there's a reason you still see them out on the road because of how they were built. So then the last question we get into is, what do we do with all the stuff that's already been made? Because we've made a lot of stuff. And that was the question that kind of came to me as a designer that I had to answer in kind of a roundabout way. So in 2008, I purchased an old beat up motorcycle from this fellow here named Ricky. This is a real picture. It is not staged. And yes, the dog just happened to be there in the picture. And I bought this old beat up Honda motorcycle. I didn't know much about it. All I knew is I wanted a wrench project and wanted something to work on. Actually, I think it was 2007, maybe 2006. I hadn't finished school yet. I was still in school at U of H, so I bought this thing as a project. And I didn't know anything about it. I've been doing car work previously, but I had never done motorcycle work. And this isn't the bike, but it was about that shape, plus a front wheel, but it was rough. It was a rough, been sitting for a long time outside, beat up object. So I would say maybe slightly better than that, but not much when I bought this thing. And the challenges I faced was, I didn't know where the parts were for. I couldn't find the parts. There was no information for it. Nobody knew what it was. And there was no place I could turn to get that information. So I was kind of on my own to figure it out a little piece at a time. And yeah, you start revealing stuff. You start going to the junkyard. You start talking to people. But even in the age of the internet, not that long ago, I had a difficult time figuring out how to fix this old motorcycle. And it took many months to do it. In fact, it took me a year and a half just to get the motorcycle to run on my own. That's how long it took me, 18 months of kind of diligently working on it. That wasn't riding, that was just engine running. So that's when I understood about this parts information knowledge exchange as being a core piece about keeping something out of obsolescence. And I fast forward a couple of years, this is kind of post recompute. This is what I'm doing now, which is Common Motor. And this manifested out of the similar need. I ran across a fella who needed help fixing up his old motorcycle. Then I found more people. And it just kind of happened by chance. I wasn't looking to do it. And people kept asking me, well, how do you fix this thing? How do you get parts for it? Can you show me? Can I take lessons from you? And what was kind of a side hobby ended up evolving into a business of applied sustainability. And so Common Motor kind of formed out of this need for people to answer these questions. People who needed parts, information, and knowledge exchange to fix their old motorcycles. And so Common Motor is a support company. And what we do is we specifically support it's an envelope of Honda motorcycles built in the 1970s, those specific families of bikes there. And what we don't realize is that Honda built hundreds of thousands of these and sold them in the US from the 60s to the 70s. A lot of them are floating around out there. However, basically Honda made their money on them. The dealers made their money on them. They're done. They're looking to the future. So dealers don't want to mess with them. Honda doesn't care. So there's people who have these things that had nowhere to turn for the answers on support. I call it a 10-year window. I know a lot of you may not know this, but cars and motorcycles and stuff are usually only supported for 10 years from the date of manufacture. So dealers a lot of times won't touch things that are older than 10 years old because it makes it difficult there. So yeah, even something that's not that old in good shape, a lot of times they don't want to touch because it's over 10 years old. Luckily, the internet facilitates a lot of things. So it facilitates parts, information, and knowledge exchange to create a DIY community. And so taking advantages of the internet and all the things that it facilitates, we can start to do this ourselves. And finally, people like motorcycles. It's a passion product. It's a hobby product that people have a lot of interest in. And, you know, in a certain regards, there's a level of cult status to it. People are really into their hobbies and projects, and enough so that they'll invest the time and energy and money into it to make it happen and not throw it away because they see that there's value there. Here's a quick shot. This is our homepage of our website, and it starts off with just parts, being like, hey, let's look at parts and what you might need for your bikes on the front end, based on, you know, the family of models that you're dealing with. More specifically, here's some examples of the parts we have. Now, it isn't just about sourcing parts and having parts available, but there's a lot of inaccuracy in parts. So if you're repairing something, you want to make sure that the thing that you bought, the part you bought, fits correctly and works correctly and has all the little bits and pieces in it to make the repair. There's nothing worse than having either too many pieces because a repair kit is supposed to cover a big range of things, or not having the right ones, or just being confused about what you got. And there's a lot of confusion in that experience. So we want to make sure that we're very accurate and down to the point of how perfect all these parts are to repair the product properly, because it's just one less hurdle to deal with. A couple examples of parts here that we make, some of them that have been discontinued. The one down in the right-hand corner there is called a triple tree. They're notoriously cracked on certain models, and the secondary market on them was outrageous. So we had them reproduced. We had to make a new one, and we made them better than the original ones because they were obsolete. You had one more part to keep the bikes going on the road. But all these are parts that we manufacture to help people repair their bikes. But beyond the actual parts is information. We run a knowledge base. We write articles on how to do the work yourself and what to look for, especially when you're dealing with something that's 50 years old, and the hurdles you go through in trying to figure this out with minimal tools and doing it in real time. So we have a lot of information that we publish about that, and also a lot of videos. We make a lot of video content showing the how-to of these different rebuild processes and adjustment processes of these bikes, because it was never in depth. You know, a lot of the documentation that was written 50 years ago was assuming you were a factory technician working at a dealership. And even that documentation is a little bit, you know, it has holes in it. It's not as thorough as it could be. So we're now doing thorough documentation so people can do things themselves and make the repairs themselves. So, you know, basically the design of Common Motor isn't so much about the product, it's about the experience and information architecture needed to facilitate the repair and give that empowerment to the user. And I'm going to end on this little video here. This is Ben. Ben is only currently a shop member and staff member, but he started off as just a hobbyist interested in bikes. And he is a example of the kind of people who are wanting to do this type of work. So we're going to play a little bit of this video here, kind of show you Ben's experience.
Hey, this is Ben here with Common Motor. I'm here today with my 1972 Candy Panther CL350 K4. So I got this bike in Tennessee 3 or 4 years ago at a CL100 and was looking to upgrade to something a little bit bigger. Found this gem in McMinnville, Tennessee, and rode it about halfway home after paying $1,000. And there was an awful sound. Metal started spewing out the exhaust. Clunk, clunk, I don't know. It was a terrible sound that one never wants to hear while on a motorcycle. My buddy came and picked me up off the side of the road with his trailer, and I called the guy I had just purchased the bike from, and he was very accommodating. Didn't want to leave a bad taste in my mouth, and he said, I don't have another bike, but I do have a K0 1968 CL350 engine that he would give me, and it would be my responsibility to swap it out. Ooh, that was more than a project than I wanted to get into. But I was resolved. I'd already fallen in love with Candy Panther, and that's that. Got to make it happen. So here's what I did on old Candy Panther. Threw a new set of tires, new set of brakes, put a new front fender, or new old front fender. The old one was cracked. New levers. That's not a lever. Yeah, okay. New set of cables. Cracked my original headlight, so popped the new one on with the LED. New brake light switches. New black levers. New grips. I stripped a helicoil that I found in my spark plug and had to get a new top end. So I just ended up doing a whole top and bottom rebuild. Rebuilt the carbs, switched out the factory air boxes for the pods, made a little clean triangle, put a smaller battery box in, switched out the old CL linkage to just an easier gear shift. New mufflers, new shocks, put on a new back rack for those camping trips, cut the back fender a little bit, and downgraded to the smaller tail light. Downsized is what I meant. Downsized. You don't want to see my...
Anyway, I think you guys get an idea. Ben is a great example of the audience that we're serving with this, and there's people around the world who have that same passion to want to fix and repair their things, but need the resources to make it happen. And so I want to share that with you guys.
Hey, this is
Hold
Ben
on.
here.
Let's go to the next slide, and that's where I'm going to end. This is that's all I got for now. We're talking about sustainability and what we're doing now. So that's that.
Well, thank you so much, Brenden. This is amazing, from your recomputing to common motors. Yeah, it's very amazing. I very appreciate. So now we have not much time left. So anyone, we opened up for the questions. Any questions to Brenden regarding anything about sustainability in design?
Hi, Brenden. I just had a quick question. So for common motor, like for bits that have to be, how do you find the logic suppliers in manufacturing to be
I can't. I didn't hear the question.
Yeah. Who? In the Miles. Yeah. Would you raise your voice a little bit? Yeah, we couldn't hear clearly.
Yeah, it's still. You gotta have to talk louder.
All right. What about now?
Totally got you now, man.
Yeah, that's great. Miles, yeah, that sounds great. Go ahead, please.
You're muted, Miles.
Yeah, I was talking directly into the phone before. Could you hear me now?
Great.
I can hear you now. Yeah.
Okay. Sorry about that. So for bits that have to be, for motorcycle parts that have to be rebuilt, how do you guys find reliable manufacturers or suppliers for these old parts?
Good question. It is the answer is a constant struggle to find companies that are going to make a part. And not only is it their ability to make the part, but it is, can we afford to have the part made? Right. So a lot of times when we're looking at scale manufacturing, a company wants to say, okay, you have to make a minimum run, or MOQ, minimum order quantity. Now, I'm at the point where I deal with companies and MOQs in the hundreds to thousands. So I might approach a company and say, hey, I want to make this particular type of rubber part, right? It's a molded rubber part. So I understand the process of how the part's made, and I'll find a company that deals in that type of process manufacturing, send them a sample, say, hey, can you make this, et cetera? And then they will get back to me and they'll say, okay, you got to make 500 of them. Here's the price. Here's the tooling cost. Can you afford it? Sure. Other times they might say, hey, we don't want to mess with this. Or you have to make 100,000 of them to make it viable. And I'm like, I don't want 100,000 of them. I want 1,000. So
Right.
it's constantly dealing with manufacturers, I would say, who are willing to play ball. Some of them are great. Other ones are, unless you're going to buy 100,000 or 10,000 or 20,000 of that product, they don't want to do business with you. And so I'm always kind of digging and negotiating. And so it's a back and forth, back and forth. On top of a lot of manufacturers are overseas, and so we have language and cultural barriers as well that can impede that, and there's time. So I showed that picture of the handful of parts that we make. There's that piece in the lower right-hand corner, we call it triple tree. That was 18 months in development right there. I found a company that actually manufactures those parts for Yamaha and Suzuki in South America. They're the supplier for them. And I was like, all right, you guys make this type of part. Can you make this one? And they said, sure, but you have to buy, I think at the time they said you had to buy 250. And they gave me a quote on the price. And I said, all right, I can afford that. And had to pay for the tooling cost and pull the trigger and hope that it's right. Anytime you do anything, you get a part made, you're always like, man, I hope we got it right, because I don't want to sit on 300 parts that don't fit properly.
Yeah.
So it's a constant challenge. It's no one easy thing, but the more and more you do it, the better you get at finding companies who are willing to make certain things.
And you said that some of these manufacturers, or like some of the original manufacturers, the OEMs, they don't really care about products past a certain point, right? Like 10 years or something. Have you ever run into any sort of like patent issues?
You're talking about patents?
Yeah.
Well, patents are kind of a weird thing. Depending on what the nature of the patent, you can go around a patent, but really we're talking about objects that were, at least in the motorcycle sense, we're talking about things that were made 50 years ago. As far as Honda's concerned, they've moved on and they're making robots and airplanes now. This is way under the bridge. If anything, they're kind of happy to see that we're supporting some of their older products and that they're still relevant out there and they're still out on the road.
Right.
So haven't run into any of that kind of stuff at all. And I really don't think we're going to, because it's not in their interests. It's not in your interest to chase after something that's, a part that sells for, $80 retail that just helps someone fix their thing. Like there's just not enough, I think, money there. Now, if it was, you're copying it and you're making, 100 million of them and you get them away for free, that the scale of it might change that. But I think right now, no, everything is too small.
Right. Okay. Interesting. Thank you.
And then the other part of it is you just got to do it and see what happens. At this point, I'm not worried though.
Okay. Interesting.
All right.
Thank you. Any questions for?
Hey, Brenden, it's Kevin. How are you?
Hey, Kevin, how you doing?
Good, thanks. Thanks for setting this up and attending.
Sure. Well, thank Jeff for asking me to be part of it. I appreciate it.
Yeah, it's fantastic. Makes you really think as a consumer of products. But the question I have for you is, do you see, anecdotally or otherwise, any information on the original manufacturers seeing that maker community, seeing that community of interest around their product and circling back, either from a marketing perspective or from an input to product use perspective, outside of let's say?
It would be nice. You do see some, like for the sake of Honda stuff, you do see Honda, like old legacy Honda stuff, show up in some of the advertising, recognizing their history. But I don't, as far as embracing a community that's doing stuff, not so much. Probably the best example of that I've seen at least in the motorcycle world is via BMW. BMW is very supportive of their legacy products, their older products, and so much so that you can still buy a lot of original BMW parts from BMW to keep the older bikes on the road. So that's probably the best example I've seen. I was at a trade show a few years ago, and I saw that BMW had a huge display as part of their booth with a bunch of older brand new parts for older bikes on display, showing that, look, we still have a bunch of this stuff available. We support our older bikes, but BMW is probably the best example, at least with the old Airhead stuff that I've seen. Outside of that, not as much.
Interesting. Thank you.
Mm-hmm.
Good. We can take probably, yeah, we are exceeding the time a little bit. Maybe we take one more question. Any of you? Well, maybe I can raise the last question, Brenden.
Sure.
Since we have quite a few our students here. They are the young next generation designers. So I really want to kind of learn from your perspective, because you live in this world for so many years, to pay attention to the design and sustainability. So to the young designers, we're going to be, they all going to be employed into the company, right? They're running and designing the new things every day. So what be their perspective or the philosophies, or the best practice for the young designers in their day-to-day job? So,
well, I'm going to refer back to some of the things we talked about in our presentation. There's so many things as a designer that are put on your plate to do, and I don't know if we've talked about design kind of being like it's a layer cake, right? There's lots of layers to it, and we have to understand not only all the layers of the cake, but we have to understand the ingredients. We have to understand the recipe. We have to understand the process of the thing we make. It's not so much about the icing on the cake. A lot of times as designers, especially in school, you're excited about certain things. We're always looking at the icing. We have to understand, well, no, what's the recipe and what does the cake taste like? And so that scope of things to keep in consideration is much bigger than maybe initially thought. Especially, most consumers don't think about it. As designers, it's kind of our responsibility to think about it. And that's why I want to present some of these ideas for sustainability. And not that all of these are the golden ticket answer, but as you're working on a project or you're working on a design, whether it's a consultancy or manufacturer, are you able to bring that layer to the equation, or you add that layer to the cake and it still works? Everything else still works with it. So, and that's where good design comes together, because all the ingredients have to come together to be the recipe. So we're the recipe makers. So we have to understand the recipe we're making and all the ingredients and why they're important, and be able to sell that idea, or at least pitch that idea to the people who make the decisions, because it may not be you as a designer. You might be dealing with somebody else in the company. It's like, this is why this is important. Let me show you why, and being able to defend your point and show those as relevant, on top of being able to do whatever else you're tasked to do as a designer.
Thank you very much again. So, and this is our first design series, and thanks everyone for coming. And this is recorded and will be posted on the IDSA under our chapter site, so other people can view it. It's a very, very good sharing, and I very appreciate Brenden. Thank you.
Thank you, Jeff. Thank you, everybody, for participating and being here. And any questions, you got my contact there on the slide, or Jeff can put you in touch with me, and happy to talk more.